Okay, let's say we have that reaction. And let's say I tell you for this reaction, delta H is negative. What does this mean? What does it mean when delta H is negative? Beteken hy is exothermic. Okay, meaning that if I draw this, it will look like so. Nee? Hierso het ons SO2 en O2 en hierso het ons SO3. Okay, at the top we have the activated complex. This is delta H. And do you guys agree that this will be the activation energy? Okay, dis mos wat ons gisterals gedoen het. So this is an indicator of the forward reaction. En wat belangrik is wat julle moet weet is, dit beteken die terugwaartse reaksie gaan endotermies wees. Want sien gou hierdie dan in reverse. If we're going from the products back to the reactants, do you guys see that we end on a higher level than we started? So as die voorwaartse reaksie exothermies is, beteken dit die terugwaartse reaksie is endothermies. And that will always be true, because remember, for the forward reaction, you're going from reactants to products. For the reverse reaction, your products become your reactants. So then we're going from that state of energy back to the original state of energy. So as die voorwaartse reaksie endothermies is, beteken dit mos hy tel energie op, né? Voorwaartse reaksie endothermies beteken hierdie kant is die energie hoër as hierdie kant. So then the reverse reaction will go from a higher state of energy to a lower state of energy, meaning that it is exothermic. En dis belangrik vir julle om dit te weet. En moet dit nie, ek wil amper sê moet dit nie oorkompliseer nie. Dit soos wat hy daar staan, is altyd die voorwaartse reaksie. So the graph as it is drawn there, or the reaction formula as it is drawn there, is always the forward reaction. So if you can identify whether the forward reaction is endothermic or exothermic, then the reverse will just be the opposite of that. Okay, alright? Goed, dan die laaste ding waaroor ek met julle moet praat, het ek gister soort van mee begin. En dit gaan oor katalysators. Let's do an endothermic one. Okay, stem julle saam, dis endothermies? Okay, if I add a catalyst to this, it looks like this. So sê gou vir my, wat is eintlik die enigste ding wat verander het? Wat noem ons dit? Activeringsenergie. That's the only thing that actually changes. Do you guys see the products is here? No, I'm lying. This is the products. None of that changed. Okay? Die rede daarvoor graad 11 is 'n suurstofmolekuule O2 het 'n sekere hoeveelheid potensiële energie in daai verbinding. Dis die werk waaroor ons geskiep het. Okay? You guys remember those bonds that they gave you values? Ons gaan mos nie dit doen nie, nee. Maar wat julle hier moet verstaan is 'n suurstofmolekuule het 'n sekere hoeveelheid potensiële energie wat opgesluit is in sy verbindings. All the different molecules have a certain amount of potential energy locked up within its bonds. So byvoorbeeld 'n dubbelbinding sal meer energie in hom hê as 'n enkelbinding, because it's stronger. So it'll take more energy to break, but it will also release more energy when it forms. Okay? So hierdie gaan nie verander nie, want jou produkte en jou reaktants het mos presies dieselfde gebly. So the state of energy that they are in will remain the same. The only thing we're doing when we are adding a catalyst is we are also almost giving the reaction a shortcut. Wat ons sê, hier is 'n roete wat minder energie gaan gebruik. Dit is nie so duidelik op hierdie skets nie, maar hy kan nooit onder daai wees nie. The energy can't be below that, because then it won't go to the other energy state. Onthou, hy wil altyd in 'n stabiele vorm wees. So ons kan nie 'n katalysator bysit wat om onder een van die twee energieë sal sit nie. It just gives us a route almost of least resistance. So normally when we are looking at a catalyst, and you guys don't need to know that for this test, but it normally gives you a surface that the reaction takes place on. So hulle het op 'n stadium, ek weet nie of hulle mee doen nie, het hulle platinum plaatjies in karre se exhaustpype gesit to avoid pollution. Want op 'n platinum plaatjie kan jy koolstof isoleer en dan is dit weer net suurstof wat in die lug ingaan, which isn't an issue. So dan bou die koolstof soort van op daai plaatjie en dan kan jy dit mos nou net afvee en weggooi, wil ek amper sê. So dan is al minder koolstofdioksied wat in die lug ingaan. I don't know if they're still doing that. I don't know if it was, worth saving the planet or anything. Maar dan wat gebeur is die platinum neem nie deel aan die reaksie nie. Dit is net 'n plaatjie waarop dit kan deelneem. So a catalyst doesn't partake, it's just an area due to the chemical properties of platinum, it's a good catalyst. Julle gaan nog baie om te doen kry. Okay, ek wil hê julle moet gou vir my gaan na bladsy 259 toe. Okay, hy lyk so. Dan sê hulle vir jou die volgende is 'n energiediagram wat die energie gedurende 'n chemiese reaksie aandui. Then they say name the energies from 1 to 3. Wat stel hierdie ene voor? Ja. Easy enough. Ne? What does 2 indicate? Activation energy, but with a catalyst. Okay. En wat wys 3 vir ons? Enthalpieverandering, delta H. Okay. Do you guys agree that this will be the activation energy for the reverse reaction? Sien julle? As ek gaan van daai onderste een tot by die geaktiveerde kompleks. Stem julle saam? Dit sal die aktiveringsenergie wees vir die terugwaartse reaksie. So hulle kan vir jou so iets ook vra. Okay, then they say, does the graph represent an exothermic or an endothermic reaction? Maklik, né? Jy kyk net na die grafiek, exothermies. And then they say, write down a formula for calculating delta H. That will always be okay, ek gaan net nommer 5 nog saam met julle doen. Is dit so erg nie? Okay, hulle sê vir is die potentiële energie in kilojoule per mol. Then they say the contact process is used to produce sulfuric acid, which is needed in high concentration for industrial processes. The basis of this process involves the oxidation of sulfur dioxide in the presence of vanadium oxide as a catalyst. So, daai stippellyntjie is met vanadium dioksied by. Nee, net oksied by. But the process is 2SO2 plus O2 yields to SO3. Alles in die gasvorm. Study the graph not drawn to scale, which indicates the change in chemical potential energy for above mentioned reaction. Use the reaction equation and the graph when necessary to answer the following questions. Is the forward reaction exothermic or endothermic? Justify your answer by calculating the value of delta H for this reaction. So stem julle saam vir 5.1 exothermic. But we need to prove that with a calculation. So I'm going to say delta H is equal to H of the products minus H of the reactants. So H of the products is negative 197. H of the products, 0. En dit gaan wees kilojoule per mole. How do I know that? Because that is what is written on the y-axis. Yeah. So delta is kleiner as 0. Meaning that it is exothermic. Okay, so ons het hom gestaaf met 'n berekening. Write down the activation energy for the forward reactions in the absence of vanadium oxide as a catalyst. So nou wil hulle weet, wat gaan die aktiveringsenergie wees vir die solid line is mos hierdie stuk. Now this one is easy to read off because it starts at 0, né? Maar sê nou maar sy produk, sy reaktanse se energie was 100. Dan jy mos net gesê daai 1580 minus 100 is die aktiveringsenergie. Do you guys agree? Jy wil hom van sy reaktanse tot by sy geaktiveerde kompleks vat. So this will be a value that we can easily read off the graph.
I don't understand why they put as catalyst.
That just means that it is the catalyst.
Then how is that not the dotted line?
They say in the absence. So there's no catalyst then. In the absence of a catalyst means the reaction takes place without a catalyst. So the dotted line is in the presence of a catalyst. Lydia!
How is that the catalyst and then they say there's no catalyst?
So reaction can take place with a catalyst or without a catalyst.
But the one we were looking for is a catalyst.
No, absence of catalyst. Is the catalyst there if it's in the absence of the catalyst?
Got it. Took a while.
Oh, good. Okay. Then they say, if we assume that 1580 kilojoule per mole is involved to break the bonds of the SO2 and O2 molecules, how much energy is released when the new bonds are formed? So dit is van hier af tot daar. Okay? Because that's the formation of the products. So then we're going to say eintlik kan ons maar net die twee bymekaar tel. Ek het hom in my kop uitgewerk, check hom dalk net gou. Good. Okay. And then they ask, determine the activation energy for the reverse reaction in the presence. What does this mean? Is the catalyst there? It is there. Okay. So, ons werk na die dotted line toe. Stem julle saam? But we're working reverse reaction, so we're going from here to there. No? Because they're saying the activation energy of the reverse reaction. So then we're going in this direction. Yeah. If they were asking for the activation energy in the presence from just like the normal reaction, you would have gone from there to there. But remember, reverse reaction means we go from products back to reactants. Okay. Is it alright?